Hey, so I thought I would break down this question that you're having with this, and you feel free to share this with them. You're playing cards with friends. Your turn to deal. Car has a mass of 2.3 grams and slides 0.35 meters along the table before it stops. So we have a card here. We'll just draw it like a box, like this. Just pretend it's along the table here, and it slides. It goes from here to here, travels from there to there, and that distance it travels is 0.35 meters. If the coefficient of kinetic friction, so that means there's a friction here, mu k, is 0.24, what was the initial speed? We would like to know the initial speed here. Now, this is a bit of a combination of kinematics and forces, because we're talking about coefficient of kinetic friction. But if we're asking for initial velocity, I always think about we're going to start with the kinematics approach. We're going to list out our 5 variables for kinematics. And then we're going to say, like, okay, what do we know? Well, we know we travel from there to there. We also got to set direction. We'll say right is the positive direction. So we know from there to there it travels a displacement of 0.35 meters. We want to know the initial velocity here. We know it stops, though, right? So we know at this point the velocity is 0 because it's come to a stop. And we don't know the acceleration or the time. So unfortunately, we cannot use kinematics yet because I need one more piece of information to solve this problem. I either need the acceleration or the time, because in kinematics, I need to know 3 quantities to solve for any of the other quantities, and I only know 2 of them right now. So one of the things we can do is we can find the acceleration. That's where the forces come into play, because F net equals ma, right? We can find the acceleration if we knew something about the net force on them. So the first thing we want to do in a force problem is I was going to draw the free body diagram, right? So in this case, gravity acts downwards towards the center of the Earth. Then we think about what's touching it, all right? The normal, there's a surface, so it exerts a normal force perpendicular. Normal means perpendicular, so it's perpendicular to the surface. And then we have friction. Now, friction runs parallel to the surface. That's the rule. And because this is moving to the right, the way it's rubbing, the frictional force is going to act to the left. Okay? And then the acceleration is going to be to the left here, right? Because it's going to eventually come to a stop because the net force is that way. So then what do you do next is then you do F net equals ma, but you have to do the x and the y direction separately. So let's say in the x direction, the net force is only the force of friction. There's only one force horizontally, and that's force of friction. And that equals the mass times the acceleration. And in the y direction, there's no acceleration. So let's say we say up's the positive direction. You would say the net force is Fn minus mg. And that's because the upward force is positive, the downward force is negative. When we do the net force, we just simply add them up like that. That equals the mass times the acceleration. Now, this thing is not accelerating vertically, up and down, because it's only going to the left and right. So this part is 0. Because the acceleration is only pointing to the left. There's no upward component, no downward component, so it's 0 in the y direction. So that means Fn minus mg is going to equal 0. Or Fn is equal to mg. Okay? So, our goal is to find the acceleration, so I need to know the force of friction. Well, this is kinetic friction. Why do I know it's kinetic friction? Because it's rubbing against the surface, as opposed to static friction, which is a little bit different. But kinetic friction is equal to mu k times the normal force. Okay? So, but we now know what the normal force was. It was mg. So we can plug that into there and get mu k times mg is equal to ma. If you divide both sides by m, they cancel. You get the acceleration equals mu k times g, which is 0.24, because they told us what the coefficient of kinetic friction was, and g is 9.8. So we're going to get 0.24 times 9.8, and that equals 2.35, 2 meters per second squared. Now be careful. The acceleration is pointing to the left. So we can fill in a number, but you got to be careful here. Because we said right was the positive direction for our kinematics, the acceleration to the left is actually going to be negative. And that's because you have to establish a direction. In this case, I said right was positive. Displacement was to the right. Initial velocity was to the right. But acceleration is to the left, so we've got to make that negative. But now that I have 3 quantities and an unknown, I want to pick the equation that relates these 4 variables. And there's only one kinematic equation that's going to relate these 4 variables. It's this one. That's how I choose the kinematic equation. So this is going to be 0 squared is v0 squared plus 2 times negative 2.352 times 0.35. And then you can multiply that. Oops. Times 0.35. I get 1 minus 1.6464 equals 0. You can move that over and you can solve for v0. It's going to be the square root of that. And I get 1.28 meters per second. So this is kind of like a combination. You have to understand how to set up your kinematics equations using that standard process for kinematics. And then you have to do your dynamics part, doing the free body diagram, F net equals ma.